Hey everyone, and welcome! Today we're going to get into something that is, frankly, a game changer for any modern data center, the integration between Cisco's ACI and VMware's vCenter. We're going to talk about how to build this seamless, totally automated bridge that stretches your network policies from the physical world right into the virtual world.
Okay, so here's our game plan. First, we'll talk about why we even need this integration, the problem it's trying to solve. Then we'll walk through the entire workflow step by step. After that, we'll break down the key building blocks, see how policy actually gets pushed across, and then for the big finale, we'll see what it all looks like from inside vCenter. Let's do it!
All right, so let's set the scene. You've got these two different universes living side by side in your data center. You have the physical network fabric with all its smarts and policies, and then you have the virtual world, which is just chaos, right? VMs spinning up, moving, shutting down constantly. The big headache has always been, how do you keep these two in sync without drowning yourself in manual config changes and support tickets? And that really is the million-dollar question, isn't it? How do you make it so that the second a developer spins up a new VM, it gets the right network, the right security rules, the right everything, automatically? You know, without having to call the network admin to trunk a new VLAN every single time. There has to be a better way.
Well, there is, and in ACI, the answer is the VMM domain. Think of this as the intelligent bridge, or maybe a better way to put it is, it's the automated translator between these two worlds. It's an object you create in ACI that establishes this direct line to vCenter, and it's a two-way street, which is critical. ACI pushes policy down to the virtual switches, but it also pulls information up, so it always knows what's going on in the virtual space.
So how does this bridge actually get built? You know, what are the nuts and bolts? Let's walk through the whole 10-step process. We're going to see what the ACI admin does, what the VMware admin does, and how it all comes together. This is where the automation really shines.
And this right here, this is our map. This diagram shows the entire dance between the two systems. You've got the APIC admin on the left and the virtualization admin on the right. Just watch the flow of arrows between the APIC, that's the brain of ACI, and vCenter. It's this beautiful automated handshake. Okay, let's take the first 5 steps. It kicks off with the ACI admin creating that VMM domain. That action alone starts the conversation with vCenter. Once they're talking, the APIC literally reaches into vCenter and creates a brand new distributed virtual switch, a VDS. At that point, the VMware admin just has to do one thing: attach their ESXi hosts to this shiny new VDS. As soon as they do that, ACI uses protocols like LLDP or CDP to figure out exactly which physical switch ports those hosts are connected to. No more guesswork.
So for the second half, we're all about policy. The ACI admin takes their application network policies, which ACI calls endpoint groups, or EPGs for short, and just links them to the VMM domain. The APIC instantly translates that EPG into a VMware port group and tells vCenter, hey, go create this for me. The policy gets pushed down to the physical switches, and now the virtualization admin sees these new port groups pop up ready to go. Their final job? Just assign VMs to them. Done.
And this, right here, is the magic. This is why we do all this. The entire painful, error-prone process of manually trunking VLANs to your hypervisors, it's just gone. It's completely automated. And as a huge bonus, the ACI fabric now has perfect visibility. It knows exactly which VM is sitting on which host and plugged into which physical port. It's a game changer.
Okay, so we've seen the how. Now let's double-click and look at the what. What are the actual building blocks that an ACI admin needs to put together to create this VMM domain policy in the first place?
This diagram shows it all really well. The VMM domain is that central object, and it's basically assembled by pointing to a few other key policies. You need to tell it about the vCenter controller, you need to give it a pool of VLANs to play with, and you need to tell it where it's allowed to connect in the physical world using something called an AAEP.
So let's quickly break these down. The VM controller info, that's just the login details for vCenter. Simple. The VLAN pool is a block of VLAN IDs you set aside and say, ACI, you're in charge of these now, use them as you see fit. The attachable entity profile, or AAEP, sounds complicated, but it's not. It just defines which physical switch ports are even allowed to be part of this VMware integration. And finally, the EPG association, well, that's the final step where you actually connect your network policy to this whole setup.
All right, so the bridge is built, the foundation is solid, now it's time to actually get some traffic flowing. Let's see exactly how we take those network policies, our EPGs, and push them from the physical fabric right into that virtual environment where our apps are running.
So this is probably the most important concept to grasp.
In the old world, with a physical domain for, say, a bare metal server, you used static path binding. That meant a network admin had to go into the CLI and manually assign VLAN 100 to interface 1/5. With a VMM domain, it's all about dynamic path binding. ACI just grabs a free VLAN from its pool and automatically programs it everywhere it needs to be, on the switch port and on the vCenter port group. It's a total shift from manual to automatic.
And here's where it gets really powerful. Because an EPG is just a logical container for policy, it's not tied to any one place. Look at this. You can have one web-tier EPG with all its security rules and stretch it across two completely different VMM domains. Maybe one is your production VMware cluster and the other is a Microsoft Hyper-V environment. It doesn't matter. The policy is consistent everywhere.
Now this works the other way too. You can have just one VMM domain, one integration with vCenter, and it can serve up networking for tons of different applications. Every time you associate a new EPG, like your web EPG or your app EPG or your DB EPG, the APIC just dips into that VLAN pool, grabs the next available number, and creates the port group. It's just so efficient.
Now, you do get a choice. When you're connecting an EPG to the domain, you can use dynamic VLAN mode. This is the default, and honestly, it's what you want 99% of the time. You just let ACI do its thing. But if you have some legacy reason, maybe an old appliance that's hard-coded for a specific VLAN ID, you can use static VLAN mode. This lets you override the automation and say, no, for this one EPG, you have to use VLAN 205. You still get the automation, just with a little more control.
And this is cool. You can see exactly what this looks like in the ABIX's user interface. On the left, that's the default. You pick Dynamic, and you don't even have to think about VLANs. But if you need to, you just click over to Static, as you can see on the right, and a little box pops up for you to type in the exact VLAN ID you want to use. Super simple.
Okay, we've done all the configuration inside ACI. The bridge is built, the policies are defined, everything's linked up. So let's do the big reveal. What does the virtualization admin see when they log into their good old vCenter client?
And there it is. This is what success looks like. Right inside the vSphere client, you see a new folder and a new distributed virtual switch, all created by ACI. And the best part? Look at those port groups. They have meaningful names that match our EPGs, and if you look to the right, you can see the VLANs, 1181, 1182, all assigned automatically from that pool we created. The vAdmin didn't have to do a thing.
So what does this all mean? It means we've achieved true, seamless, policy-driven automation. The network now provisions itself based on application requirements. We've built an intelligent fabric that extends all the way from the physical network core right to the virtual network card of every single VM.
And that kind of leaves us with one last question to chew on. If the network team can now automatically create and configure objects inside the virtualization platform, where does one job end and the other begin? It really breaks down those old silos and forces everyone to work together in a new way. Something to think about, for sure.